Hello viewers, today we will talk about tensile testing. In tensile testing, IS standard, IS 1608, ASTM, E8, E8M are used. What is the difference between E8M and E8M? The gauge length is of two types, 4D and 5D. E8 is for 4D and E8M is for 5D. This is a tensile testing machine. The tensile testing machine has a capacity of 600 kilonewtons. The jaw is made of hydraulic gripping and is made of a hardened tempered material. Hydraulic gripping is kept because when the sample is tested, when the load increases, there are chances of slippage. If there is slippage, there may be variations in the reading. Hydraulic gripping has a plus point that there are no chances of slippage. Now we will see the dimension of the sample. We will first feed the dimension of the sample to the system by checking its dimension, then we will process it by clamping the jaw. Now we will test it. This is a round specimen. In a round specimen, we have to check its diameter. We will check the diameter in its vernier. We will check in the vernier. Its diameter is 12.5 millimeters. In 12.5 millimeters, as we have discussed earlier, it has 4D and 5D. That is, we can mark the gauge length of 4 times of diameter and 5 times of diameter. If we mark 4 times of diameter, then its size will be 50 millimeters. And if 5 times of diameter comes, then it will be 62.5 millimeters. We can check according to E8 and E8M. We have marked the dimension of 50 millimeters according to 4D. This is the marking. Now we will clamp the sample in the machine. Now we will enter the data in the sample. This is its control panel. And we have connected the software with this control panel. The data of the control panel will come in the software. Now we will enter the input data in the software. We will generate the ID name of the sample in the file name. We have to select the size of the sample. The sample was a round sample, so we have selected a round sample. The sample's dia is 12.50. We will enter it in this. The gauge length is 50 millimeters. We will enter it in this. And we will mention the ID of the sample in this. We will save this value. After saving, we will check again whether the input value is OK or not. After that, we will click on Data OK. After clicking on Data OK, we will start testing the sample in this. The sample has been clamped here. First, we have inserted a round jaw as per the sample because the sample was a round sample. Now the jaw has been clamped. After clamping the jaw, we will lock it. To lock it, the sample has been locked. We will lock the lower portion later because it is a dead load of the machine. We will release the dead load and then lock the lower portion. We have started the sample testing. The sample has been clamped for the sample testing. The machine is on. First of all, we have to keep both the right and left valves in the closed position. Both are in the closed position. After that, we will start the sample. We will turn on the machine. After turning on the machine, we will slowly open the right valve. By opening it, you can see that the value is decreasing. The dead load of the machine is being reduced. After reducing, a certain dead load will automatically stop. We have to wait till then. The dead load has stopped. After that, we will lock the right lock and we will tear the load. After tearing the load, we will lock the lower portion of the sample.
After locking, a certain load is generated in it. We will slowly reduce it. After reducing the load, we will tear the load again. After tearing the load, we will start the test. After starting the test, the connectivity of the software with the panel is proper. After starting the test, we will apply the load. Gradually the load is increasing. After that, the strain rate is measured. If we control the strain rate in the controller unit, then the range of the testing will be correct. You can see the strain rate here. The strain rate is going in the controller unit. The range of the test is 20 millimeters per minute. The load will gradually drop because the elongation has started and the breaking point has started after elongation. That is why the load is starting to go down. As the load goes down, the sample will come to the stage of breaking. The sample has been broken. Now we will close the machine and declamp the sample. After breaking the sample, we will measure the final gauge length. After measuring the final gauge length is 64.42 millimeters. The initial gauge length was 50 millimeters and the final gauge length was 64.42 millimeters. The sample has been broken. Now we will feed the final gauge length to the system. The final gauge length is 64.42 millimeters. We will measure the final diameter for the reduction of the final area. We will measure the final diameter for the breaking area. The initial diameter was 12.50 millimeters and the final diameter is 7.50 millimeters. Now we will close the machine and save the result.